In the last tutorial, we show you how to create a brand new bank projects and how to create clusters, how to create directories in your file system, and then how to create symbolic names in iPhone Studio as clusters and how to set them up correctly. So just as a review, if you go to the file system, you can see that we have the bank projects directory, and then under that we have three directories: bank, root, and tests. So the root directory contains the application class that contributes as the entry point for execution. So whenever you launch your system for runtime execution, application.make will be the feature to execute first. And anything that branches from there, we'll just take it from there. And in this tutorial, what we will do is to add a new class called account for the bank. And we'll also show you how to create a constructor for the class and how we can do design by contracts, which means you can write contracts or specification even before you write the code. That's a very, very important message for you to carry home when you actually when you actually take this course. So design by contract means the contracts are themselves sometimes more valuable than the code. Although with the contracts themselves, your system cannot just be executed for your application purpose. But the contracts are very important to ensure whatever that you're going to implement is correct. So we are trying to build the products right. And also we are trying to build the right products. Both of them we want to satisfy. Okay, so let's get started. So let's go again to the terminal, and I am now in my workspace for 3311. So I'm going to launch the current version of iPhone Studio for this term, summer 2015. Running the background, enter. So now, different from the last tutorial where we actually have to click on the basic application and say create to create a new project, because we have already created a bank project and it is actually shown here. So if it is not shown here, what you have to do is to say add projects, and then you actually just browse to where the bank projects that you created from the last tutorial is stored. But in this case, it is shown, so I don't have to worry about it. So make sure I click on that, and then I would say, so under the Open Projects panel, so bank project is shown with the correct path, and also the location here is also correct. And let me just open that and make sure it is compilable. Okay, so now we want to add a new class called account. So where should we put account into? As I said before, any class that actually goes out of the regions of the three clusters we have created so far will be considered as non-existent. So either you have to create a new cluster to hold the account class, or we have to put account class to one of the existing three clusters. And I think bank cluster should be a reasonable place to go to. So now we want to add a new class into the bank. So there are two ways to do it. Either you can right click on the bank cluster and say new class, or you can see this icon here, say add a new class. Either way, let's say I go this way. Add a new class. I want to call that account. Okay, so here you can see under general panel, there are different options for you. So the deferred is equivalent to the abstract class idea in Java. If you select a class to be deferred, that means that class will have some features with their definition, with their body implementation undefined. In which case, they cannot be instantiated directly, and their descendant classes have to make those features non-abstract in the iPhone term, to actually have the effect the features there. We'll talk about these terms more in the lecture later. And the expanded, which we'll also talk about later in the lecture, has to do with the semantics of the objects. So expanded should be contrasted with referenced. So typically what you see before in Java is actually referenced, which is the opposite of expanded. But anyway, you don't have to worry about that too much at this point. Okay, so here we actually have the option of generate the creation procedure. So creation procedure means constructor. So to initialize the objects. And also, so also default feature classes. But so these are just some auxiliary features that you may want to use. You can explore that yourself. Let's just do a very simple skeleton generated and see how we can build from there. Okay, as for parents, so here we account, for our purpose of the account, we don't actually need to inherit any code or to redefine or to effect any features from the parent classes. So we don't actually need to put anything. But later on, when we want to add a testing class, we will actually have to inherit from the ES_test, which is a class from the eSpec library that we added from the previous tutorial. Okay, so now let's create the account class. Okay, always remember, first of all, to actually make sure this node header here presents the first thing that anyone who's going to read your code will first see. Or later on, you actually, well, the point is you really want to document your code well. So let's put author here. And also you want to put some documentation. So to do this, I propose that we actually should document the requirements for the bank account somewhere in the projects. I propose to do the following. First of all, I want to create a new, so this is back to the file system for my projects. So now I'm now under bank projects. Let's create a new directory. Let's call that docs for documents or documentation. And let's go into it. And I want to store, let's say, a text file listing all the informal requirements that I'm going to implement for this bank projects. And I already have that typed in my text editor. I would just have to, so these are the 6 requirements that we actually went over in the lecture last time. So let's just save that into the docs folder for the projects. Let's just call that bank requirements.txt. Okay, let me copy this and close that. And then let me go back to iFlow Studio. So now I want to paste these requirements as the documentation as part of the documentation for account class. But it seems like I cannot fit those several lines into a single line. So the way to do multiple line documentation in iFlow is by doing a string block. The way to do that is to have colon, left angle brackets, left square brackets, and then left square brackets and right square brackets. And now hit enter from here, and anything you put here will be considered as a comment. So let me just paste that here. The indentation may not be the best one, but that would do for this tutorial. You can fix the implementation later yourself when you are creating the projects. Let's make sure this can compile, because it's very often that if you're trying to copy some text from elsewhere into iFlow Studio, there might be some special symbols that will cause your project not to be compilable anymore. So let's compile. Okay, that's good. So now I have some reasonable documentation for the class. Oh, right before that, so this I should say what the class is supposed to do. What is its responsibility? A class that represents a bank account that allows customers to deposit and withdraw. And if you're not happy with that, you can always refine your description later. But it's always good to put something first there and then try to gradually refine that or revise that until you are satisfied. And remember, one of the important course learning outcomes is you have to know how to do professional documentation. And documentation in the code is also important. Later on, if you want to extend your software, you have to read over your documentation again to refresh your mind. So whatever hard work you do now will benefit you later. Okay, that's about the documentation at the class level. So now, let's do some coding. Well, although I said before, test-driven development is really about you can write tests before you can write the code. But to actually make sure your test cases can compile, you have to write some basic interface for your class in order to make sure your test cases compile. So let's just do some basic coding, but we'll do just the minimum amount of coding such that we can write some basic tests to set up the testing infrastructure. Okay, so for the account, so now we can use the feature keyword to bookmark different sections in our account class. So I can say this part is called attributes. Whenever I say save, you can see that on the right panel here, under the features panel, we do have the attributes. You can see whenever I click on attributes, it's going to link to this location here with the feature. Okay, so for example, if I have feature and I say constructor, you can see the constructor now, the bookmark appears here. So imagine that if you have a very long list of features in your class, so whenever you declare the feature, you can actually see a very like from the bird eyes view at the features panel. It doesn't mean you really have to put a single feature under each feature section. You can put several features that belong to the same feature category. Okay, we'll see how that's going to work. So let's say for the attributes, for the accounts, because we know from R1 that account balances never exceed the credit limits. That means the credit limits, first of all, credits is never negative. And credits actually allows your balances to possibly go negative. However, the extent to which your balances may go negative depends on how large your credit limit is. For example, let's say if your current credit limit is 10, that means your account balance can go only down to -10, but not lower. If it goes lower, that means you breaks the data integrity of your account class. So we really have to define some constraint once we declare the attributes. I'll show you how to do that. To define the constraints as class invariants. Okay, first of all, let's define the two attributes we need for the purpose of the account. The first one is balance, and for the purpose of this tutorial, we just make it integer, just for easiness. And the way to declare attributes or in IFO is very different from the case in Java. In Java, you actually say the type first. You would say integer and then balance. This is what you would say in Java, but in IFO, it's different. You want to say the attribute name first and use the colon sign. You can think of the colon sign as the set membership operator that you learned from the previous 2090 math course. So you're saying that I declare balance as a state variable that is a member of the set of integer values. Okay, so it's not a string value, it's an integer value. Similarly, I want to declare a credit attributes of type integer. Okay, and now if I simply leave my class like this, that means throughout the lifetime of any account objects, they can any combination of the balance and credits will be allowed. So as I said before, the R1, so that means R1 might well be violated. Let's say if we have some example, let's say currently the balance is -20, but the credit is only 10. You can see the credits is simply not sufficient to support the negative balance, right? So what we have to make sure is we also document our constraint on the state attributes, the data, in such a way that the integrity as defined by the business rules or the requirements is respected. Okay, so what we should do here is to declare an invariant section. So invariant is a list of predicates that will be evaluated at runtime before and after the execution of each feature. But in the case of constructor, because we are going to begin with the lifetime of an object, so only after the object is initialized will we check the truthfulness of the invariance. Okay, I will show you example very soon. But now for the invariance, so first one, so it's always good. So now we are writing our very first contracts for the IFO project. So it's always a good practice to have some tag. But I'll show you what the tag is. So first of all, the first one is we want to say the credits is always non-negative, and it would be very good documentation practice to actually have a tag. So there are two ways to do this. Either you can say double dash to say credits is always non-negative. So this is good. However, an even better way to do this is to create a tag for this particular constraint. Okay, I will call this constraint as, so the naming convention in IFO is lower cases delimited by underscore. So I would say credits non-negative. So this is the name of the tag, and then I'll put a colon here, which means whenever the IFO runtime is going to check this constraint, if this constraint is violated at any point, the IFO is able to report back to me with this tag to say the Boolean constraint that's associated with this tag has been violated. So it's really a way to trace back to your original specification. So it's always good practice to put a tag for invariance, precondition, postcondition, and later on in the lecture we'll talk about looping variants. Okay, so we don't actually quite need that because the tag itself is quite self-explanatory. Right, so the second invariant we want to write is to characterize the formal relationship between the credits and balance. Okay, so what I want to say is what R1 over here states, that account balances never exceed the credit limits. So let me say balance not exceeding credits. So I want to put a Boolean expression here, like a predicate. So I want to say the current balance, which might be negative, plus the credits, which has to be always non-negative, should be non-negative. Okay, we actually discussed in the class why such invariance is valid. Okay, so now, up to now, we actually have two attributes, and we have defined the constraints upon the values that these two attributes might take throughout the lifetime of the objects. So for any values and for any combination of the values for balance and credits that do not satisfy both this and this will be disallowed as the legal value for the account. Okay, that's why the invariant is a really valuable source for constraining for maintaining the integrity of your class. Okay, so now we have attributes, so now we need to have a way to initialize the objects for account. We'll talk about classes and objects later on in the lecture as well, but since you actually learned that already in the Java classes before, so it wouldn't be too new to you. So hopefully that still makes sense. So now for the constructor, we want to create a constructor. So now a typical name is called make, which means to make a new object for the account. And make may or may not take some parameters for initializing the attributes. In this case, let's say we do want to pass some preset credits for this particular account. So we would say a credits, and remember the parameter name cannot clash with the attribute name. That's why we choose a underscore. And remember, again, the naming convention in IFO is to have underscore as the limiter between lower cases characters. So a credits is a type that's compatible with the credits attributes, and anything that occurs between the do and block is the body code implementation for make. Even before we do that, we want to do the side contracts. So let's do some documentation. So we do some comments for this constructor first. Let's say it is supposed to initialize an account with a credit which is supposed to be as a number for credits and 0 balance. So this is our documentation for the feature, and you can also maybe make more documentation as you wish, but that's good enough for now. So now, we don't actually want to program right away. We actually want to specify what the constructor of this account class is supposed to achieve. So what we want to do is to have a post condition for the make. So in IFO, to specify a post condition, you have to say ensure. So that's a keyword in IFO. So ensure means whenever the body of the body implementation of the constructor make, so anything that happens over here, anything that happens in between do up to ensure, after they have been executed, then whatever that's specified from here to here must be satisfied. And also, at the same time, the invariants must be established. So the constructor, to recap, the constructor of each constructor of a class has to establish two things. They have to establish the post condition, and they have to establish the invariants. Okay. Now, so what post condition should we have? Typically, you have to numerate the constraints for the list of attributes. So we should say something about balance, and we should say something about credits. So for the balance, we simply just want to say 0 balance, because we expect when some account is first initialized, the balance should be 0 before any deposit or withdrawal occurs. So 0 balance means we want to say balance is equal to 0. And you have to pay attention to this sign over here. So the equal sign here is very different from the equal sign you see in C or Java, because this operator is actually overloaded in those two languages. But in IFO, equal sign here means exclusively just equality, which means this here is a Boolean expression, and this another symbol for assignments. So now let's do the post condition for the other attributes, which is credits. So we want to say credits properly set. So you can see that this is a tag and that is a tag. So later on, when IFO runtime system is checking to see if whatever implementation I do satisfies the post condition here, if any of them actually is violated, the IFO runtime is able to tell which one and tell me, for example, this one is violated or this one is violated. We'll see examples later. Okay, so here I expect to see credits, the new value for credits is equal to the value for a credits, because a credits is already declared here, so I can use the code completion support from IFO Studio, which is simply just control space, like in Eclipse. So if I type control space, so I can have the code completion. In this case, I can put a credits here. Okay, let's compile. So this is still compilable. So now I still don't want to write a code yet. I want to show you something that's really valuable already. So you can see now what we have got is informal documentation at the class level and also documentation at the feature level. Both of them are informal, but they're still valuable. And we also got contracts. So we got two post conditions for the constructor, and we got two invariants of for the class. And these contracts are executable, which means at the runtime they will be checked against the code implementation that you're going to write. Okay, and as I said before, the current view in the editor is the editor view. So you can see the view bar over here. You can, if you put your mouse there, it says basic text view, which means this is a basic view for you to edit your software. And let's go to the one that's called the contract view. We actually use a flat view later to actually do to set the breakpoints and to run the debugger, but that's not the point. That's not the focus for this tutorial. So let's go to contract view and click on that. You can see that. So sometimes you might find it convenient to actually show only this window here, but you can come back later. So just double click on this tag over here. And now you can actually see, you can see the whole view of the class. But if you want to go back to where you were, just double click again. So now we are back to the Explorer's view. So let's double click this. Okay, you can see now we are in the contract view of the account class. So you can see the header here, and you can see the account. And here you can see we have the balance and credits attributes. And here you can see we have the constructor, and it shows only the post condition over there with the proper text with documentation and also informal description without showing any code. Even if later on we put any code in there, it wouldn't show either because this is a contract view for the account class. And we also have the invariants here. So later on when you actually submit any report for your work, we always ask you to actually submit a contract view because contract view actually, as far as your customers may be concerned, they only want to see the contract view of your class rather than your implementation code. In some way, they don't quite care how you actually achieve their expectation. As long as they are achieved, they're happy. They don't care how you do it. Okay, so again, what we have seen in the contract view is like the what part rather than the how part. Okay, let's go back to the basic text view and let's double click on this tab again to go back to the Explorer where the Explorer is available. So now what we want to do is to add some implementation in the make that will actually establish both the post condition, the two post conditions here, and the two invariants here. So typically we're going to do assignments for the state attributes. So now I need to somehow set a balance to something using the colon equal, which is the assignment symbol. So always remember assignment, which is colon equal, is in a different category of language construct as the category for equal sign. So let's say balance should be assigned to 0 because that should be initialized to be 0. So this line here is called a assignment instruction. This line here is called a Boolean, or I should say it's called a predicate equality. So this is of type Boolean, and this is of type instruction. So they are completely different. Don't get confused ever. So now, how should we set the credits? Because our intention is, the reason that we include this parameter is because we want to preset some credits for a new customer's account. So we'll say credits, which refers to the state attributes here, should be assigned to the arguments. And now we can use the code completion. You can see now, in this context, we can actually assign the credits to either the balance, the credits itself, or to the make. But in this case, we simply want to assign to a credits. That should be the right way to do it. And now let's compile. Okay, so this is our first attempt to write a code to satisfy the post conditions and class invariants. Again, let me just go bring you back to the contract view, and let me double click on that. You can see even though we put some code into our into the body of make, but in the contract view they are not really shown. As I said before, how you actually implement your system such that the specifications are met is not of the customer's concern. What they care is what's your intention really, and your intention is really documented using contracts. Okay, so now let's do a final thing before we end this tutorial, because in the next tutorial we are actually going to do we can already do some test cases for the account. But now one thing we have to do is what's going to be the constructors for this account class. So although I said this feature tag here is called constructor, but as you can see, this is simply a comments. So it is informal. So IFO compiler is not going to tell that make is actually a constructor. In some way, IFO is very flexible. So constructors can have any name you like. And because of such flexibility, so you must tell IFO that I want to include some features as a potential constructor at the runtime. So as opposed to Java, of course, in Java, if you have the capitalized name for the class, then that means it's a constructor. But in IFO, that's not the case. So here, up to now, make is only a normal feature that you cannot use that to initialize or to instantiate any account objects. If you want to enable that for other clients of the account class to initialize to using make, all you have to do is to declare that. And right after the class header here, so you would say use the word creates. So we call this the create class. So declare the list of possible features that, oops, let me do it again. Okay, declare the list of possible features that can be used as constructors. Okay, so now I want to say make is one of them. Okay, so now let's compile the system and let's see. Oops, there might be something I did wrong before, but somehow I modified the name of the account, but that's okay. Let me fix that. Okay, so now I recompile and it is okay. Right, so now we have done what we are supposed to do for this tutorial. In the next tutorial, we will actually show you that with this minimum amount of code, with contracts and implementation, we can already write some test cases, and we actually create a new class that will dedicate for the purpose of testing. So stay watching.